Caley-Maria Cavan from Cheltenham Ladies College. Come on up. Now, Caley enjoys sport, particularly hockey and lacrosse, but she also says that she loves to figure out the way things work. However, she's keeping her options open for a future career. I can tell you what she lists: law, politics, interior design, film directing, producing, and acting. I mean, the world is your oyster with all that, isn't it? Ladies and gentlemen, please put your hands together for Caley-Maria.
Hello. I'd like you to close your eyes for the first part of my talk. Don't worry, I'm not going to do anything sinister. Okay. You're on a beach. The waves crash calmly, a wind blows. Beautiful oranges, yellows, and reds graffiti the sky. And the sun is just about to set beyond the flat horizon line. Just as it does set, there's a beautiful green light shimmering above the horizon line, and then it's gone again. You can open your eyes now. So how on earth does that all happen? Well, technically it doesn't happen on Earth. This all takes place in the atmosphere. Now, the atmosphere is full of tiny particles and molecules, and these are excellent at redirecting the sun's light. Now, the sun's light is actually every colour of the rainbow on my artistic drawing, you can see here. And each colour has a different wavelength. So in terms of this redirection, which is called scattering, it scatters colours with shorter wavelengths more easily than those with longer wavelengths. So blues and violets are scattered more easily. And this means when we look up at the sky, they are entering our eyes from all different angles, and that's why the sky is blue. But what about all the other colours at a sunset? So this happens because when the sun is above us in the sky, it has less atmosphere to pass through than when it's on the horizon. Because when it's on the horizon, because of the spherical shape of the atmosphere in the Earth, there's more atmosphere for it to pass through, meaning more particles and molecules. So these particles and molecules redirect the blues and the violets completely out of our vision, leaving the longer wavelength colours like reds, oranges, and yellows to reach our eye. And that's what gives the skies such a beautiful colour. But what about that green flash? Now, I hadn't heard of that before, and I'm sure you hadn't either, but I came across it in my research, and I thought it was really cool. And basically, the atmosphere acts like a prism to the sun and its light, and this means it refracts it. Not only does it refract the sun, but it also refracts its light. So when we see the sun on the horizon line, we're actually seeing it like a whole diameter above where it actually is. So when the sun has fully set, it's already been set for 120 seconds. This refraction also separates out the colours of the sunlight according to their wavelengths. And so when the light is coming away with the sun, it leaves with small time intervals, each colour at a time, and green is the last to leave, visible to our eye, giving that beautiful flash to end a wonderful night. Thank you.
We got some fans in. Thanks for that. I've heard of the green flash and tried to spot it a few times and been unsuccessful, but really great to actually hear what causes it. So thank you, just from me, just a little personal one. Who would like to start us off? Yeah, Jamie.
Yeah, fascinating. I've never heard about the green flash either, so thank you for introducing something completely new into my understanding. One thing, maybe a difficult one, when you were doing all your research, what did you discover that most surprised you, that you thought, wow, I didn't know that?
I didn't realise how the atmosphere affects light. So, like, really a green flash should be blue, because blue has, like, the shortest wavelengths. But that requires really specific conditions of the atmosphere and the particles and the molecules. So I didn't realise, I thought kind of light just like entered, but it's to do with the shape of the atmosphere and it refracts it, and actually what we see is really different to what's really there. So,
thank you.
Anyone got a follow-up? Sarah, yeah.
Fascinating presentation, thank you so much. Let me ask you, what were you most worried about before today? Was there anything that you were scared of today?
I think just like freezing up, I guess, but just like staying relaxed is fine. And also I had to redraw my diagrams quite quickly because they got my water bottle leaked, but it was all okay. So, yeah, it's fine.
Well done for overcoming that. That's great. Thank you.
Nicely done. Thank you very much.